and it is in our everyday life also. Physics is our everyday life. So, like, if I ask any question about history, when India got independence, like that, correct or not? You know the dates, correct or not? If I ask who discovered neutron, then maybe some of you will answer it, correct or not? Or when neutron was discovered, correct? Because every year we celebrate Independence Day, okay, correct? So that is a thing. Every day, every time, again and again, you are studying something, it will be remembered, right? So physics is also like that. It and it is in our everyday life. Electricity is there, light is there, correct or not? Specs. You are seeing specs. How specs are helpful. Suppose a person cannot read properly, specs will help. It is physics only, correct? Telescope is there. So it is physics. So physics is in our everyday life, correct? So it is good. Okay, just tell yourself it is easy subject. So for entrance exam also you will learn it. Okay, two things are there. You like the subject, you like reading books, and now you have to crack the exam also. Correct or not? You have to clear the exam. So you have to learn how to solve questions. Okay, so it is all about your brain. Just start from small questions. That's why I'm saying you should have books also. Books are very important. Okay, what books are there? Tell me. Yes, yes. If you still don't have books, you get it. Okay, fast. RLS is good book. RLS, the good thing about RLS book is number of questions are more number of questions, more MCQs. Small MCQs are there. Small questions, big questions, easy questions are there. Some difficult questions are there. All types of questions are there. Okay, so you can. So the specialty about this book is it has easy questions also, difficult question also. Okay, Ariant is there. If you saw SC Verma also, it is also good book like thermodynamics. Thermodynamics for NEET also. People say SC Verma is only for JEE, correct? But no, for thermodynamics, especially heat and thermodynamics, HC Verma is good book. Okay, so you can solve questions in HC Verma also. RLS is there, Ariant is there, Disha is there, MTG is there. So get these. NCRT is there, NCRT. Exemplar is there, exemplar. NCRT exemplar. Okay, clear? So make sure you get these books. Some of you are having it. If not having, you get it. Okay, correct? Okay, fine. So what is the next? Now, yesterday what we were doing? Average force finished. Okay. What is the formula for average force? Delta P by delta T. Let's solve some more questions. In vector form, what is the formula? F vector is equal to delta P vector by delta T. If it is a straight line only, for a straight line, we can manage with right and left. Right will be positive, left will be negative. Correct? If it is not a straight line, no straight line, so we can use I cap, J cap. Okay. So for plane, in plane, use I cap, J cap. If it is 3D, means that is space, so that is I, J, K. All three will be used. Okay. So let's do one question on straight line, and one question in plane, and one question in space. Okay. Three questions let's solve based on this. So let's solve one question. Write down. A ball of mass 200 gram going right, or you can say east. This is east, south. Okay, this is west, this is north. This is upward, downward. So ball of mass 200 gram going east, hit by bat. Okay, we play like cricket. So ball is coming like this, ball is coming like this. Bat is there, bat will hit the ball like this. Hit by bat, and the contact time is given. Contact time with bat is 0.02 seconds. Contact time is 0.02 seconds. If ball returns back, okay, speed also not given. Okay, note down. A ball of mass 200 gram going east, speed also note down. 60 meter per second. What is the initial speed? 60. If the ball returns back with 80 meter per second, find average force. Find average force. Okay, this is also known as impulsive force. Other name for average force is impulsive. What is impulsive? What is impulsive? Sudden, correct? Like suppose you are hitting the bat, you are hitting the ball with a bat. So the time taken is more or less? Less. The ball is coming like this. The contact time is very less. So something which is taking very fast. So it is known as impulsive. Okay. So force acting for very short time. You can note down. What is impulsive force? What is impulsive force? Force acting for short time, like football. Suppose football is there, player is coming, it will hit the football. So for how long the player and football are in contact? 1 minute, 1 hour, or milliseconds? Football and player, football and player. Okay, this is the player and football. Player is hitting the football. So the body of the player, the legs and football, they are in contact. For how much time they are in contact? It is more time or very less time? Very less time. So force is acting. During that time, force is acting. Okay. During that time, force is acting. That force is known as impulsive force. So any answer? Minus 1400. Correct. Okay, you can use this formula. So delta P can be written as m delta V, because you know that P initial is equal to m into V1 and P final is m into V2. So delta P can be written as m into V2 minus m into V1. So m V2 minus V1. So this is delta P, correct? So mass is 0.2 and V2 minus V1. V2 minus V1. Tell me what is V2? It is minus 80. Very good. So V2 is minus 80. Then minus V1 is you take plus. So minus 80 minus 60 divided by time taken is 0.02. 0.02. So your answer 0.2 by 0.02 into minus 80 minus 60 minus 140. Correct? Now you solve this. So you can write this 0.20 by 0.02 into minus 140. So after decimal 2 digits are there, 20, and this after decimal 2 digits are there. So you can remove the decimal simply. So 20 by 2, correct? 20 by, or you can do like multiply both numerator denominator by 100. So 20 by 2 into minus 140. 2 to cancel. So minus 1400. Note down. Minus 1400 Newton. Minus 1400 Newton. Okay, clear? Everyone? Minus 1400 Newton. So this is 1D. Straight line. Right, left, plus, minus. Correct? Now let's solve one question in which plane is involved. Plane. Like suppose ball is coming from south going towards north, and player will hit. Here player is standing, player will hit the ball, and now ball is going west. So how to solve now? Same question you can solve. See, initially ball is going north. Initially ball is going north. After hit from bat, it is going west. Ball is going west. Ball is going west. Find average force. Take mass and initial speed, final speed from previous question. What is the mass in the previous question? 200 gram. So 0.2 kg. Time delta t 0.02 second. What is the initial speed? 60 meter per second. Final speed 80 meter per second. These are the speeds. Okay. Means magnitude of velocity. Magnitude of velocity. So you can draw diagram. So initially the ball is going north. Finally it is going west. So how much is average force? So now we cannot use plus minus. You have to use I and J, correct? Because plane is there, plane is involved. So what is initial velocity vector? Initial velocity vector. Vector. What do you use for north? J cap, very good. So 60 J. And what is final velocity vector? Minus 80 I. Minus 80 I. Okay, minus 80 I. Previous question, it is just east and west. East you can take plus, west you can take minus. So final answer is minus 1400 Newton. So minus means left. So you can say 1400 Newton west. Correct? You can use I cap, J cap here also. How? You will write V1 vector is equal to 60 I. And what is V2 vector? Minus 80 I. So what is delta V vector? Final minus initial. So minus 140 I. Are you getting? Minus 80 I minus 60 I. So minus 40 I. Correct? Same answer you will get. So come to this question. So what is delta V vector? Final minus initial. So minus 80 I final minus initial 60 J. So minus 80 I minus 60 J. Okay, clear? Easy, right? So this is delta V vector. So what is the average force formula? Average force formula, delta P vector by delta T. So delta V means mass into delta V. Mass into delta V. Mass is 200 grams, so 0.2 kg. 0.2 into delta V. You can take 20 common also. Delta T is 0.02, correct? Like this you saw. So I'm taking 20 common, okay? Minus 20 common. Minus 20 common. So 0.2 into minus 20 common. 4I plus 3J divided by 0.02. Now 0.2 by 0.02. 0.2 by 0.02. Many students do silly mistake here. Okay, careful yourself. When you see calculation is there, automatically you slow down. Okay, decrease your speed here. Okay, up to here you will write fast. In exam I am talking about, in test. Okay, normally student remember all these, formula also you remember. When time for calculation is coming, you are more careful. Okay, like you are suppose driving a car. You are driving a car. When road is empty, you drive very well. But suddenly village is coming, dogs are sitting, a turning is there. How you become more concentration or what? Less concentration, more concentration. Okay, so same thing, calculation mistake happens here. Many students are losing marks in this. Whole year you are memorizing the formula, all everything, north, south, east, west. You are understanding very well, but here you will do silly mistake. So you have to be very slow here. Okay, extra 10 seconds if you give here in this type of calculation, extra 10 seconds, 15 seconds. Okay, suppose 10 numericals are there. In 15 seconds extra you are giving, especially for this step. How much time it will take? 150 seconds. Approximately 3 minutes to 2.5 minutes. 2 to 3 minutes extra. Just 2 to 3 minutes is not much. 2 to 3 minutes is not much, right or not? Extra little bit more careful you should be here. Okay, you think time is less, we should finish this question very fast. Don't think like this. Okay, so calculation is there, you extra 10 second, 15 second you give, otherwise silly mistake will happen. Okay, so you have to avoid it, avoid the silly mistake. So now you solve 0.2 by 0.02. What is this? 20 by 2, so 10. Okay, this is 10. So 10 into minus 20, so minus 200. So minus 200 into this 4I plus 3J. 4I plus 3J. Okay, understood? So this is the force. So tell me what is the, first you tell what is the direction of force. What is the direction of this force? Then we will talk about magnitude. This is minus is there. So and 4I plus 3J, 4I will be this way, 3J, but minus is there. So reverse it. So minus 4I and minus 3J. Correct or not? You can see like this, 200 minus 4I minus 3J. So minus 4I means this, and minus 3J this. Correct? Minus 3J. So this is the direction of force. This is the net. Understood? So tell me, what is this angle alpha? So what is tan alpha? Opposite by adjacent. 3 by 4. Tan alpha 3 by 4. So what is alpha? 37 degree. So what is the direction of force? Direction of force? 37 degrees south of east. Very good. Okay. So force acts along, average force acts along 37 degrees south of east or west? West. South of west. 37 degrees south of west. Alpha is 37. Okay, alpha is 37. So you have to measure 37 from west. This is west. From west 37 you measure, okay, like this. 37 from west. 37 from west. Note down. Towards south. Okay, so this is the direction, correct? 37 degree south of west. Direction clear? Now magnitude. So here we have 200. And what is the magnitude of this? Square root 4 square plus 3 square. What is this? Square root 4 square plus 3 square. 16 plus 9. 25. Square root of 25? 5. Correct? So 200 into magnitude of this 5. 200 into 5. 1000. Correct? So what is the magnitude? 1000. Magnitude is 200 into 5. So 1000 Newton. Okay. So average force is 1000 Newton. Note down. Average force is 1000 Newton. Direction is 37 degrees south of west. Okay, clear? 1000 Newton. Okay, finish. Only 2 examples are enough now. Okay. Now let's go back to our topic. So, thrust. We are discussing about thrust, rocket. So, thrust is a force. Yesterday we discussed it. Thrust. What provides thrust? Example is balloon. Suppose balloon is there, and you have filled helium gas or normal air also. You have filled normal air. Okay, air is there, and you have tied it with a thread, so air cannot escape. But suppose now you open the thread, what will happen? So air will escape. Now air is escaping. Air escape. So when air escape, it will have some speed because inside more pressure. Inside air is more pressure. Air pressure is more inside. Outside less pressure. When you fill when you fill air inside balloon, okay, the pressure is more inside. Outside atmospheric pressure, inside more pressure. So air will come out with speed. So with what speed it is coming out? V. So what is the formula for thrust? Yesterday we discussed V into dm by dt. Okay. So this is the thrust. Okay. So this is Newton. Okay. Remember, this is thrust. So air is escaping downward. So force on the air is downward. So force on the balloon is upward. So that's why this balloon will go upward. Correct or not? No doubt. This is the thrust. So rocket also like this. This is the rocket. This is the rocket. Okay. Same principle. The gases are ejected downward. Gases ejected downward. Gases ejected downward. So force on gas is where? Force on gas where? Downward. So force on rocket where? Upward. Okay, this is known as action reaction. Newton's third law. We can call it Newton's third law. Okay, third law. Newton's third law. Generally, Newton's first law is more important, second law important. We don't give more importance to third law, but it is important. Okay, we should discuss third law also. What is Newton's third law? You know it. What is Newton's third law? For every action, there is equal and opposite reaction. For every action, there is equal and opposite reaction. For every action, there is equal and opposite reaction. Correct? In our daily life also it is important. Suppose I am hitting this wall. I am hitting this wall. Wall is also hitting me. Are you getting or not? I am feeling hurt here when I hit like this. So wall is also hitting me. Correct? Similarly, suppose a ball is there, this is the ball and this is the bat. When ball is hitting the bat, so ball exert force on the bat. So force on the bat is where? Right side. Force on bat. So bat is also hitting ball. So force on the ball is where? Left side. Force on ball. Understood? So these are known as action reaction. They are opposite. So if this is action, so you can call it reaction. This is reaction. You can call it action also. You can call this also as action, no problem. Then this will be reaction. Why? Tell me why. Why we can call this action or reaction, then action or reaction? Why? Because both happen at same time. Both, note down, both action and reaction acts. Both action and reaction acts simultaneously at the same instant, same time. Okay. Simultaneously means same time. Note down. Both acts same time. Okay. Like for example, I'm exerting force on the wall. At the same time, wall is also exerting force. Okay. Similarly here, bat and ball, both are exerting action reaction at the same time. Okay, clear? Normally, in human being also it is there. Suppose one student is there A, another student is there B. Okay, and suppose B slap A. B slap A. Okay. Now A will think. A will think. Why? A will go to home. Think whole day. Think what happened to me today. The next day it will come very angry. A will be very angry, and A will slap B also. Understood? Can I say it is action reaction? Can I say it is action reaction? No. In physics, action reaction are not like this. Action reaction happens at the same time in physics. Okay. So in our daily life, we cannot relate this example. No. It can be related. Suppose B is already knowing A is coming and A is about to slap. B knowing already. And immediately exit at that instant, both slap each other. Okay? Both slap each other, then we can say it is action reaction. Correct? So, same time, both happen at same time. Okay? There is no waiting time. Now action acts on bat and reaction acts on ball. So action reaction acts on two different bodies, no doubt. Action reaction, action and reaction, action and reaction acts on two different bodies. Okay. Sometimes theory questions they ask statement types, assertion reason. Suppose I am saying action reaction acts on two different bodies. True or false? True. Okay. Let's take one example on this. One example we have seen. Action is acting on bat, reaction is on ball. Or action is on ball, reaction is on bat. Suppose this is the block of mass m. So downward force, what is the downward force? Mg. What is the upward force? Normal. So who is exerting normal force? Surface. Surface push it. Surface push it up. Surface is pushing the block up. Correct? If this is action, so what is the reaction? Can I say Mg is reaction? If this is action, can I say Mg is reaction? No, because action reaction acts on different bodies. So what is the reaction? Now you see the surface. Suppose this is the surface. So this block is also exerting force on the surface. Okay, so this is the normal from the block. So block, push, surface, down. Block, push, surface, down. We can see one example. Normally in the solid floor we don't experience it. Suppose you are standing on the sand. Suppose this is the sand. If you go to any beach, so sand is there. Now stand over the sand. What happens to sand? Sand is like that only, or it will what you call? It will go down. Sand like this. Depress, huh? What you call? Uh, like this. Initially sand is like this. When you stand over it, it looks like this. Are you getting? Like this. Depression. So this proves that sand is experiencing force. Are you getting? So what is that force? Normal. So sand is exerting normal on the person. Sand is exerting normal on the person upward, and the person is also exerting normal on the sand downward. Okay, clear? So action reaction acts on different bodies. Okay, okay, fine. So these 2 3 points you remember. Okay, action reaction act simultaneously. They act on different bodies, and they are equal and opposite. They are equal and opposite. Action reactions are equal and opposite. If action is 10 Newton right side, reaction is 10 Newton left side. Okay? They are equal and opposite. Okay. So we discussed one question also. Like suppose there is a triangular platform. There is a string here, and here one pulley, clamp, and one person is standing on the platform holding the string like this. Okay. So this is the string. If you draw free body diagram of platform, this is the triangular platform. Okay. What is the shape of this triangular? Note down. Triangular platform. So person and triangular platform, they are in contact. So for person, if you consider person, the triangular platform exert force upward. If you consider platform, so person exert normal force on the platform downward. So these are action reaction. Okay. Then mass of the person, suppose m1, and mass of platform is m2. So downward force for the person is m1g. Tension, string is there, so tension is there. Understood? And for platform also, this is the platform, but tension is here, and the weight of the platform m2g. Are you getting clear? So these are action reaction. Okay. See, platform is there. Suppose this is the platform. The person is standing. Platform exert force on the person upward. So person also exert force on platform downward. Okay, so these are action reaction. Suppose this is 10 Newton. So this is also 10 Newton. Okay, clear? Then you can remaining you have solved. Okay, n plus t. What you get here? N plus t is equal to m1g, and what you get here? T is equal to n plus m2g. Correct? So balanced. Forces are balanced. Okay, no doubt. We have discussed this before. I'm just revising. So this is balanced forces. Balanced forces, no doubt. So then you can solve this. N plus t is equal to m1g, and t minus n is equal to m2g. these two, add. So n minus n cancels. So what is 2t? m1 plus m2 g. So t is equal to m1 plus m2 g by 2. Correct? Understood? So this is free body diagram. Free body diagram. Okay, clear? Free body diagram. Any doubt you ask, okay? After the class also, if you have any doubt, we discuss. So what is t? This is the t. Then subtract. If you subtract t minus t cancel, n minus minus n, 2n. 2n is equal to m1 minus m2 g. So normal force m1 minus m2 g by 2. This is the normal force. Okay, clear? m1 is mass of person. Person mass minus platform. So this is person mass and this is platform. Okay, person, platform, triangular platform. Okay, done. If you have understood this free body diagram, these are easy, very easy to do. Understanding this is more important, and understanding action reaction. Okay, clear? Okay, understanding action reaction. Okay, fine. Now so pseudo force finished. Actually, we are doing pseudo force. So now I'm starting spring force also finished. Okay, spring finished. Average force. Anything left? You tell me. Okay. So I'm starting new chapter now. Friction. Okay, let's start friction now. So note down. Friction. The basic meaning is opposition. Opposition to relative motion. Opposition to relative motion. Okay. Now what is relative motion? Opposition to relative motion between two surfaces. Between two surfaces in contact. So friction is a contact force. Note down. You remember fundamental forces? What are fundamental forces? Weakest gravitational force. After that, weak nuclear force. After that, electromagnetic force. After that, strong nuclear force. Strong nuclear force. We have discussed this before. All contact forces are electromagnetic in nature. Remember, all contact force are electromagnetic. Electromagnetic means the force between electrons, protons. Okay, that is known as electromagnetic force. So all contact forces are electromagnetic. Suppose I am putting this object in contact. So contact force means this. So the atoms of this object at atoms of this surface, they are very close. So atoms and the electrons and protons of one surface will exert force on electrons and protons of other surface. Okay, so that is known as electromagnetic force. Normal force, tension force, these are also electromagnetic. Remember, normal force, tension force. Now we are doing friction force. What is the symbol for friction force? A small f. Remember, a small f. Generally, we will use a small f for friction force. Okay. So normal force, tension force, friction force. These all are contact forces, and these all are electromagnetic in nature. Remember, electromagnetic. Okay, let's talk about surface. Generally, this floor, one surface is there. This is also surface, correct? This pen, this is also surface. This board is also surface, correct or not? If I ask this glass, what is the surface of this board made up of? Material, glass, correct? Plastic, this wood window, glass is there, correct or not? And this is cement is there, cement. Which is more smooth, glass or cement? Glass is more smooth because I will draw the diagram. If you see the surface of glass, it will be, maybe it will be like this. If you see the surface of cement wall, then it will be like this. Correct or not? When you see this small holes are there in the wall. Okay, so when surface is like this, so we call it hills and valleys. What you call? This is known as hill, and this is known as valley. So imperfection. This is known as imperfection. Are you getting? So this surface is rough. What do you call this type of surface? This surface is known as rough. When you have hills and valleys, it is known as rough. If there is no hills and valleys, then we can call it smooth. Like for example, smooth glass. Suppose smooth glass is there. This is normal glass. A smooth glass will be like this, perfectly straight line. Okay, so perfectly straight line we can draw. So there is no hills and valleys. So we can call it smooth glass. Okay. So what happens now? Suppose this is the block. This is the block and this is the surface. I want this block to slide on the surface. So what happens if you see the surface of the block is like this, rough, and the ground surface is also rough. So what happens? They lock against each other. Lock. This is a valley, hill, hill, valley and valley lock, hill lock. Now it is difficult to slide. Okay. So suppose this valley want to go right side, this hill will stop it. Correct? Hill will stop it. So force. What is that force? The hill will exert force like this. This valley surface want to go right side. So this hill will exert force like this. Correct? What type of force is this? Vertical, horizontal, or inclined? Inclined. So this force has two components. This force has two components. One component is known as normal, another component is known as friction. Okay, clear? Normal is perpendicular to surface, friction is parallel to surface. Okay, so note down. You can draw this diagram. So this is known as resultant contact force or net contact force. Note down. This is resultant contact force. So resultant contact force is vertical, horizontal, or inclined. Resultant contact force, inclined. Suppose surface is horizontal. So resultant contact force is like this. Okay, when the surface is rough. So friction, normal. Okay, note down. So what is the formula for resultant contact force? Magnitude of friction square plus normal square. This is the formula. Note down. Net contact force. Sometimes in question they will ask friction, sometimes in question they will ask normal, sometimes in question they will ask net contact force. Net contact force. So just one line you write down. When two rough surface when no down when two rough surfaces, you understand the meaning of rough surface? If it is a smooth surface, no hills and valleys, no hills valleys, no hills and valleys. If rough surface, hills and valleys. Okay, so this is rough, this is smooth, no hills valleys. Okay, clear? When two rough surface comes in contact, no down, two rough surface comes in contact, hills and valleys, hills and valleys oppose each other, hills and valleys oppose each other, hills and valleys oppose each other. And this diagram you can draw, this diagram, draw this diagram. Hills and valleys oppose, this is the valley, this is the hill. Okay, you can try this using your hand. Suppose this is the, like this, okay, like this. I can move this hand very easily like this, but suppose like this, now difficult, because one finger is fitting here, one finger fitting here, one finger, now it is now difficult. Are you getting or not? So this is known as valley, this is known as hill, hill and valley fitting. Okay, so they are fitting. So what you call this force? Resultant contact force. Okay, so draw this diagram and this diagram and this formula. Okay, so when two rough surfaces comes in contact, hills and valley oppose each other. So friction acts parallel to surface. Remember, friction acts parallel to surface. Normal acts perpendicular to surface. Friction is parallel, normal is perpendicular. Okay, clear? Okay, fine. So friction is just a force. Remember, it is not very special. Something is special. It is no. It is just a force. It is a pull force. Remember, friction is a pull force. Next, you write down. Friction is a pull force. Okay. Okay, so let's solve some basic questions. So note down is static friction. What is a static friction? So note down. When two surfaces do not slip, when two surfaces do not slip, no slip, okay, no slide, no relative motion, no slide, no relative motion, okay, do not slip, do not slide, no relative motion, then it is known as static friction. Let's solve some example. So I will give one question. I will draw one diagram. You tell me it is a static friction or not. So suppose there is a block. There is a block. It is kept on rough surface. It is kept on rough surface. Okay. Now I'm pulling this block right side. You call it external force. You call it external force. So what is the direction of external force? Right side. So friction is acting left side. Block is not moving. Block is not moving. It is at rest. So friction is static or kinetic? Static. It is static because no motion. It is static because block is not moving. Understood? So it is balanced also. It is balanced. So you can say if I am exerting 10 Newton, so how much is static friction? 10 Newton. If you are exerting 20 Newton, how much is static friction? 20 Newton. Okay. Note down. So static friction, let's take example of the chair. So this is 10 Newton. So 10 Newton here. Now like this, it is moving. But now, not moving. I am exerting force, not moving. I am exerting 10 Newton. So how much is friction? 10 Newton here. You are exerting force but not moving. Not moving. So static friction. Suppose there is a bus. Bus is in motion. Bus is in motion. It is accelerating. Okay. Now there is a box inside the bus. There is a box inside the bus. You tell me the box is also not moving. When observer, this is the observer. This observer is seeing the box is not moving. So what type of friction acting on the box? Static or kinetic? Hmm? Is there any slipping? Is there any slipping? No. So what type of friction? Static only. Even when you see from outside, the bus is moving. Along with bus, box is also moving. So according to observer B, the friction is static or kinetic? According to B, huh? Static only. Static only. Okay. Friction is a real force. Remember, friction is a real force. Friction is real force. Are you getting or not? Okay. So whether you are seeing from outside or inside, you see that there is no slipping. No slipping. Box is not slipping. So it is always static. Are you getting? Sometimes you see, if you see a farm, there is a buffalo. You've seen buffalo is there. So buffalo is there, and crow is sitting. You've seen that crow. You have seen buffalo is running, and crow is sitting on the over the buffalo. So what type of friction acting between the crow and buffalo? What type of friction? Static friction. Okay, static friction. So for static friction, you just observe slip is not there, no slip. Okay, okay, fine. So static friction, note down. Static friction is self-adjusting, note down. Self-adjusting its value. Self-adjusting its value means 0 Newton, 1 Newton, 2 Newton, like that it can self-adjust. Okay. So let's take one example. Suppose this chair, I am exerting 1 Newton. Chair is not moving. So what is the friction? 1 Newton. If I am exerting 2 Newton, chair is not moving. What is the friction? 2 Newton. If I am exerting 3 Newton, now it is just moving. Okay. So what is the minimum static friction? When I am not exerting any force, so what is the friction? See, suppose this is the box. If no external force, so friction also no friction. Understood? So friction will oppose motion. If there is no external force, so no motion, no tendency of motion, no tendency of motion. I am not exerting any force, so no tendency. So how much friction? Right now, what is the friction? 0. Understood? So what is the minimum value of static friction? 0. So surface is rough. Surface is rough. Surface rough means it is not compulsory that friction is also there. No. Friction will be there only when external force is there. Okay, so now friction is there. See, now friction is there. When external force is there, then friction is there. So minimum static friction is 0. Okay, now you see, suppose I am exerting 1 Newton, but the block is not moving. Block is not moving. So how much is friction? 1 Newton left. If I am exerting 2 Newton, then how much is friction? 2 Newton left. Friction is 2 Newton left because block is still not moving. Okay, but you increase this force, axial force increase. So exactly when 3 Newton is there, so I will say just move. Block just move. When block is just moving, so friction is also 3 Newton, but it is the maximum. It is the maximum value. See, I am exerting a small force, not moving. 1 Newton. Now 2 Newton I am exerting, not moving. Now exactly when it is 3 Newton, it is just moving. See, it is just moving. So just moving means what is the friction also? 3. But this is the maximum value. After that it is moving. After that it is moving. Correct? So just moving means you what type of friction? Maximum static. Because after that it is not rest. It is moving after that. Okay, understood? Static. So maximum static friction is 3 Newton. Okay. So what is the minimum value? You can check. What is the minimum value? 0. And maximum value in this example 3. So we have a formula for this. What is the maximum static friction? We have a formula. So note down. What is the formula? You know it. So maximum static friction. What is the formula for maximum static friction? There is a formula for that. Mu s into n. Note down. Mu s n. Okay. Just remember, n you know already. What is n? Normal force. N is normal force. And what is mu s? Coefficient of static friction. Note down. Coefficient of static friction. Okay, coefficient of static friction. If more rough means more value. It depends on rough surface, roughness. It depends on roughness. Like for example, for glass, okay, glass it will be less than wall. Coefficient of a static friction, which is more rough, glass or wall? Wall is rough. Wall is rough. Glass is smooth. Glass is smooth. So which has a more coefficient of static friction? Wall. Okay. Let's take one more example. Suppose two papers are there. Suppose this is one paper and this is another paper. Okay. Now you put these papers in contact. Now try to slide it. Try to slide it. Maybe you are able to slide. If you put some glue in between, now you try to slide it. Now you cannot. Why? Because you have increased mu value. Are you getting or not? You can note down this example. If we put glue means adhesive, correct? So adhesive increases mu or decreases mu? Increases. If we put glue, adhesive, it increases coefficient of static friction. How to decrease coefficient of static friction? How to decrease? Lubricant. If we put lubricant like grease, oil, okay, oil, grease. If you put lubricant, then mu will increase or decrease? Decrease. Mu decreases. No doubt. Are you getting or not? So suppose this chair, this floor is rough. It is difficult to move this chair. Now you put lot of lubricant here. Very smoothly it will slide. Correct? So if you put lubricant, mu will decrease. If you put adhesive, glue, Fevicol, quick fix. So okay, understood. It increases mu. And what is the minimum value? 0. Minimum value is 0. Note down. Minimum value of mu s. Minimum value 0. Maximum value can be anything. Infinity. Maximum value infinity. Give example of infinity. Like two papers. These two papers. Suppose two papers are in contact. You can slide easily. But now you put Fevicol in between. Now you try to slide. It will not slide. Correct or not? So what is the mu now? Infinity. Are you getting? Infinity. So maximum value infinity, remember. Minimum value 0. Clear? Okay. So what is the formula for maximum static friction? Mu s n, remember. Maximum static friction, mu s n. Mu s n. Minimum 0. So let's solve some questions now. So suppose this is the block. This is the block kept on the rough surface. This is the block. Now it is a rough surface. Rough surface. Now mu s value I am giving 0.4. Mu s value 0.4. Mass is given 3 kg. Mass is given 3 kg. Now you are exerting force, horizontal force F. Like this you are exerting force. Okay? Like this. Surface is horizontal, rough. Force is also horizontal. If you want, you can note down. Block kept on rough horizontal surface. Block kept on rough horizontal surface. And horizontal force is acting. This is also horizontal. Means parallel to surface. Horizontal force acts. Force is horizontal, surface is horizontal. So you can call it parallel. Means force is acting parallel to surface. Force acting parallel to surface. Are you getting? See, you tell me force is vertical or parallel. Now force is vertical or parallel? Vertical. Now force is parallel. Okay. So parallel to surface. So parallel to surface. Okay. Now two answers you have to give. Find friction force and acceleration. Small f means friction. A means acceleration. Acceleration. Okay. Find F and A in following cases. In following cases. Okay. So suppose I am giving F value. So F value I am giving suppose 2 Newton. F is 2 Newton. F is 2 Newton. Next I am giving F is 6 Newton. F is 8 Newton. F is 12 Newton. Okay, answer. Suppose force is 2 Newton. Force is 2 Newton. So how much is friction force? If the block is not moving, so friction is same as external force. So check it. What is the maximum static friction? First you calculate. What is the maximum static? How much? Mu s n. Mu s n. So what is n here? How much is n? N 30. Good. So mu s n is 30. So maximum static friction is 30. Correct. Yes, 12. So maximum static friction is 12. Okay. You are exerting only 2. So it is less than maximum static friction. Okay. It is less than maximum static friction. So it will not move. Block will not move. Block will not move. So how much is friction? Now F is equal to 2. So friction is also 2. So friction is 2. Okay. So first question, friction is 2 and block is not moving. So acceleration 0. Now answer for second question. What is the how much force? How much force you are exerting here? 6 Newton, but maximum static friction is 12. Still it will not move. No move. It will not move. Okay, understood? So what is the acceleration? 0. And friction? Friction? 6. Correct, good. So in second case, friction is 6. Left side. Third case, you are exerting 8 Newton. 8 Newton is less than 12. Maximum static is 12. So external force is less than maximum static friction. So not move. Block will not move. So acceleration is 0 and friction is 8. Correct? Fourth question. Now what is maximum static friction? 12. And you are also exerting 12. Still it will not move. You have to exert more than 12. Okay? To move it. So acceleration is 0. Friction will be 12. Okay? Understand it. And it is purely based on practical experience. Okay? So this chair is there. Suppose you are exerting a small force, not moving. You increase the force, not moving. Now it is moving. Okay? It means I am exerting more than 12. When you exert more than 12, it will move. Up to 12, not move. 1 Newton, 2 Newton, 6 Newton, 8 Newton, 9, 10, 11, 12, 11.5 also not move. 11.8 Newton not move. 12 Newton also not move. Slightly more than 12, you exert. Suppose if you are exerting 12.1 Newton, so it will move. Okay? More than 12 means it will move. Up to 12, not move. So to move, what is required? What is the condition that it will move? Tell me. So condition for slip. What is the condition for slip? What is the condition for slip? Slide. What is the condition for slide? External force must be greater than maximum static friction. Note down. Must be greater than maximum static friction. So it will just move. And when it is moving, slipping, sliding, moving, slipping, sliding, then friction becomes kinetic. Okay? When it is moving like this, when it is moving, friction becomes kinetic. Note down. Friction becomes kinetic. Okay? So static friction, what is the minimum value? 0. Maximum value mu Sn. And suppose it is moving, so friction becomes kinetic. It has fixed value. It is not self-adjusting. Static friction is self-adjusting. Kinetic friction is not self-adjusting. Its value is fixed. What is the formula for that? Mu Kn. What is the value of friction? Kinetic friction, what is the formula? Mu Kn. Okay. And generally mu K is less than mu S. May be equal to or less. Remember this. Mu K is less or equal to mu S. Mu K less or equal to mu S. Like for example maybe mu S is 0.3, mu K is 0.2, okay? Or you can take mu S 0.8, mu K 0.6, okay? Or you can take mu S 3 and mu K 2.5, like this, okay? Examples. Mu S is greater, mu K is less. Now you solve this. Suppose this is the block, 3 kg block. Mu S is given 0.6. Mu K is given 0.4. And now you are exerting 20 Newton force. Find friction and acceleration. What is the friction force and acceleration? Okay. So how to solve? So if it is moving, so friction is kinetic. Remember. First you check whether it is moving or not moving. Okay. To solve this type of question, what is this question? Block is there. Suppose this is the block. You are exerting 20 Newton. Mu S is given, mu K is given. Okay, fine. I am asking what is friction, what is acceleration. Okay, clear? What is the first step? Check. Check it is moving or not. Check it is moving or not moving. It is moving, sliding. Moving means sliding. It is sliding or not sliding. So check mu Sn. Calculate mu Sn. What is mu Sn? Correct. Calculate mu Sn. So mu Sn is equal to 0.6 into n. And what is n here? 30. So mu Sn is 18. Now you see what is the external force? 20. It is more than this. So it is moving or not? Moving. Correct. external force is greater. External force is greater. External force is greater than mu Sn. So the block is moving. So block is moving. Okay. Block is moving. Moving means accelerating or constant velocity also. No problem. I will talk about after the break. I will discuss that acceleration. So it is moving. So what is the force right side? What force is right side? External force. How much? 20. Now it is moving. So what is the friction force? Correct. Mu Kn. Now it is kinetic friction. Friction is kinetic. So mu Kn. Okay. Mu K means 0.4 and N means 30. Correct. Good. So friction is 12. Friction is 12. Now you calculate acceleration. So Newton's second law. Unbalanced force is equal to mass into acceleration. Unbalanced force, mass into acceleration. Okay, apply this. What is the unbalanced force? 20 minus 12 is equal to ma. What is the mass given? 3 kg. Mass is 3 kg. 3a. Okay, understood? Clear? Note down. So acceleration you will get 8 by 3. Acceleration is 8 by 3. Okay, 2.67 meter per second square. This is the acceleration. 2.67 meter per second square. Okay, clear? So note down. You are excited 20 newtons. So first step is to check it is moving or not. Calculate mu Sn 18. N is 30. External force is greater. So it is moving. Moving means you can find acceleration. Now calculate friction. Friction will be kinetic. Kinetic mu Kn. Now unbalanced force is equal to mass into acceleration. Okay, done? Clear? Okay, done. Now just one more last question, then you take break. This is very important question. Now I am giving very important question. This is important question. If external force is equal to mu Sn, maximum static friction, what happens? If external force is mu Sn and mu K is less than mu N, mu K is less than mu S, then what happens? How much external force you are exerting? Equal to maximum static friction. So you will think you are exerting maximum static friction, so it will not move. Okay, but it will move because mu K is less. It will just move. Remember. So answer can be it will not move also. Okay, two answers are possible. You are saying external force is equal to maximum static friction, correct? So it will not move. Definitely it will not move. So what is the answer? It will not move. Why it will not move? Because external force and maximum static friction both are equal. It will not move. Okay, but suppose I am saying if external force is slightly greater than mu Sn, slightly greater than mu Sn, now what happens? Then it will move. Block will move. Are you getting or not? Axial force mu s n equal, it will not move. Axial force slightly greater than mu s n, it will move. Okay, clear? So how to find acceleration? If it is moving, if axial force is slightly greater, so axial force you can take mu s n, and how much is friction? It is moving, so how much is friction? Mu kn. Approximately you can take axial force mu s n. Okay. Actually, axial force is slightly greater. Suppose mu s, I'm giving one example. Suppose mu s n is 10 Newton. So how much is external force? Maybe 10.01 or 10.02. Okay, slightly greater. So external force nearly you can take mu s n. And what is the friction? Kinetic or static? Mu kn. It is moving. So friction is kinetic. So how to find acceleration now? How to find acceleration? If this minus this, mu s n minus mu k n is equal to mass into acceleration. Okay, note down. So this is a very important concept. So note, very important. So if external force is equal to mu s n, not move. What is the acceleration? 0. If external force is mu s n. If external force is slightly greater than mu s n, then it will move. Then we can find acceleration. Okay. So I'm just giving question. You take break and you can solve after a break. Mu s is 0.6. Mu k is 0.5. Mass is 4 kg. Now question is find acceleration when external force is just slightly greater than external force is just slightly greater than maximum static friction. Okay. Okay, you finish it after break. Okay. So note down. Okay, we'll continue.